Helicopter principles of flight and operation. Unlike fixed-wing aircraft, the helicopter's main airfoil is the rotating blade assembly, rotor, mounted atop its fuselage on a hinged shaft, mast, connected with the vehicle's engine and flight controls. In comparison to airplanes, the tail of a helicopter is somewhat elongated and the rudder smaller. The tail is fitted with a small anti-torque rotor, tail rotor. The landing gear sometimes consists of a pair of skids rather than wheel assemblies. The fact that the helicopter obtains its lifting power by means of a rotating airfoil, the rotor, greatly complicates the factors affecting its flight, for not only does the rotor turn but it also moves up and down in a flapping motion and is affected by the horizontal or vertical movement of the helicopter itself. Unlike the usual aircraft airfoils, helicopter rotor airfoils are usually symmetrical. The chord line of a rotor, like the chord line of a wing, is an imaginary line drawn from the leading edge to the trailing edge of the airfoil. The relative wind is the direction of the wind in relation to the airfoil. In an airplane, the flight path of the wing is fixed in relation to its forward flight. In a helicopter, the flight path of the rotor advances forward, to the helicopter's nose, and then rearward, to the helicopter's tail, in the process of its circular movement. Relative wind is always considered to be in parallel and opposite direction to the flight path. Considering helicopter flight, the relative wind can be affected by the rotation of the blades, the horizontal movement of the helicopter, the flapping of the rotor blades, and wind speed and direction. In flight, the relative wind is a combination of the rotation of the rotor blade and the movement of the helicopter.